Hello, everybody. So I believe the recording has begun. So I'm going to take you on a quick tour of how to find the resources for our virtual lab on fractional distillation. So you should all be able to now see our webpage for our course. So this first module, if you click on modules here, you'll find this fractional distillation virtual lab material module. So there's going to be three separate documents that you should reference when completing this. So this first document here, if you click, I'm going to stop share and actually take us to this document on a separate, just a Word document, so we can see it a little better here. But if you click, that's how you can access document 1, 2, and 3. So let's take a look here at what you should see once you download that. So this is the bottom of the document. Let's go back up top here. So we'll see experiment 6, fractional distillation, our modified procedure here. As far as your write-up for the lab procedure, you can reference the chapter 5 distillation, or you can just reference what's provided here. Experiment 6 distillation microscale glassware, this document number 2 here that I'm pointing to right now, that just references some of the microscale glassware that'll be utilized. And then at the end of that document, I'll show you some sample calculations. But this is our procedure here that we're going to follow. So this is virtual, but we're going to imagine that we've created this fractional distillation setup. You can also check this out in the videos below. I'll show you where to find those on this document. But instead of using a thermometer, so we've made a slight change. We've modified our setup here. We have a lab quest with a temperature probe, sometimes called a thermocouple. And then we collected our data. We're given 5 milliliters of an unknown mixture. So we don't know the mole percentage of 2 esters. And we're told that they're ethyl acetate and butyl acetate. You can look up the properties, the structure, etc., such as boiling point for these compounds. That may be helpful for some post-lab questions. And then one of the post-lab questions specifically, it asks you for your unknown mixture identifier. So my name is Allison Lucci, so my initials will be AL. You can include this as your answer on the post-lab document. So in case you were wondering if you already took a look at that last document 3, we're going to use our initials there. So 4 milliliters of our total 5 milliliter mixture are placed in a, here it's referenced as a distillation pot. But if you look at the glassware apparatus, the setup, it's actually a round bottom flask. So we're going to subject this mixture to a fractional distillation. So we'll heat it slowly so that we could record a temperature reading. So we would actually keep this data point into our LabQuest unit for every 4 drops of distillate. So as this is distilling, we're going to get 2 different components to come out of our mixture. We're going to refer to them as component 1 and 2. And every 4 drops of whatever distills out, called our distillate here, we're going to collect a data point, so we'll have a temperature graph that I will show you. And we'll have approximately 10 drops for each of these 3 fractions. We're going to collect 3 fractions total, so 1 at the start of our distillation, the first 3 drops. Then we will collect, I'll show you the graph where the steepest rise in temperature is. We'll actually have to turn up the temperature if we were doing this in a laboratory setting to increase the temperature rapidly. And that's where we would collect our next cut or fraction. And then we would collect our 3rd fraction at the end of the distillation. So we're going to then take our cuts, our fractions throughout our distillation, and we're going to perform gas chromatography on these samples. So this is our analysis section here. So in addition to our 3 fractions, we'll have control samples, so known ethyl acetate and butyl acetate pure samples. And then our mixture, that remaining 1 milliliter. So we're going to have a total of three, four, five, six different samples that we're going to have gas chromatographs generated for. These are the conditions here. So you might need this information for your post-lab document to submit. These are the parameters that we would enter into the LabQuest unit before we could run our gas chromatogram. Uh, so I'll show you where these data have been provided as far as our drops versus temperature graph, and then all of the chromatograms. Uh, this has already been done for you, peak integration. So when we take a look at document 3, I'll make note of how this was done using software called Logger Pro. So if you collected this data on your own, you would analyze it using that software. So here we have some experimental videos. The first shows a simple distillation. We will not need to know these calculations that are provided in this video. Then we have down here a theory of fractional distillation. So this is the theory behind what we're performing in lab. And then this last video here, we have both a visual of simple and fractional distillation. So the first two videos will be theory. The third will actually show the experiment being performed. So this first video down here under the analysis videos, this would show you if you were to collect data to perform these injections using gas chromatography, how you would do that. And they also show you how to analyze these chromatograms that will be produced. So similar to what I'll describe, I did using Logger Pro. We find what's called the retention time. So how the sample passes through our column, how long it stays in the column. Each component specifically will have their own retention time. So that's what that's referencing there. And then you'll see down here that a second video, including this video here, will be provided for you to show how to perform calculations. And then I'll also include this video as well. So let me stop share here, and I will walk you through shortly document number 2.